Hi everyone. Now I'm going to discuss the model number 1 8051 architecture. In foursome, it is a second subject and it has different units. Out of that, now I am going to start first unit, which carries 25 marks in external exam. In this unit, we are going to discuss regarding 8051 introduction, difference between microprocessor, microcontroller, and CISC, one-to-one architecture, Java architecture, and what are the different criteria to select a microcontroller, different criteria which are related to choosing the microcontroller, and relate to the 8051 architecture, features of 8051, pin diagram of 8051, block diagram of 8051, program status register. It's a flag register. We'll discuss different flags. After that, we'll discuss how to interface external memories to the 8051, different types of SFRs, and we'll discuss those SFRs, important special function registers. These are main concepts you can see in this first unit. Now we'll start from what will be the inside a computer. Okay, that is, you can see here inside the computer what you can see. The computer is usually used for multi-purpose applications, which is takes different instructions, it comes from the users, and it is going to process by the CPU of that computer in the binary format. Again, it is going to give the results, and here it is going to combination of hardware as well as softwares computer. And computer is mainly used for almost all general purpose applications, and some other computers are there, mini computers, like which contains microcontroller or other type of embedded systems, is used for to solve specific tasks, that is a specific application related computers, or you can say embedded systems. And here if you see the computer, it is going to perform all the functions in terms of binary. So in binary, you can say the some common terms are comes. If I say the binary process, you will see bit, nibble, byte, word, like this. Bit is nothing but a single binary digit, have only 0 and 1. Nibble is nothing but 4 bits, half byte. Byte in the sense 8 bits. Word is nothing but 2 bytes, that is nothing but 16 bits. And some other features, kilobyte, megabytes, gigabytes, terabytes. If you are studying microcontroller, in the sense you are going to measure the memory of RAM, ROM in terms of bytes. And what is size of kilobytes? It's nothing but 2 raised to 10 bytes, that is 1024 bytes. Megabytes 2 raised to 20, gigabyte 2 raised to 30, terabytes 2 raised to 40. Like this you are going to calculate the memories. Now we'll see the internal organization of computer. If you say the computer, what will be present inside the computers, it mainly has CPU, and it is designed by using the microprocessor, general purpose computer. It has main 4 components. You can see the block diagram of microcomputer. It has general purpose microprocessor, and you are connected externally memories like random access memory and read only memories, and input and output. These are connected external to the main systems. CPU is going to perform main functions according to the applications. And if you open the CPU, inside CPU, what else you can say? If you open the CPU, you can see the block diagram. It has ALU, arithmetic logic unit, which is perform the different arithmetic operations. While performing the different operations, You need some other registers to store the intermediate results or temporary results, and you need to read the address of datas, and you need to store the result of your operation in different registers using different register. Like it has data bus, address bus, and control bus to perform all these operations, which contains program counters, instruction registers, and you have the different registers A, B, C, D, like that. These are the main function blocks you can see in the CPU of your computers. And if you open the microprocessor, these are important components you can see that already you discussed. ALU, accumulator, working register, program counter, clock circuits, stack pointer, and interrupt circuits. We'll discuss all these things one by one in next concepts. And main working of microprocessor is it mainly used to perform the general purpose. There is no any specific purpose of task it will not perform, and depends on the applications. You have to connect different peripherals like memories and timers, IO ports. This one makes the system complex and more cost, and it makes more difficult to write the programs. So to make easier the programming and cost everything, you are going to go for microcontroller mainly today's used in almost all embedded applications. If you open any embedded system, it has a microcontroller. Main use of microcontroller is here it has a on chip, or you can say system on chip. So the system on chip in the sense it contains all on chip RAM, ROM. You can see the block diagram of single chip computer. That's why it is called as single chip computers. You can see the block diagram. It has on chip central processing unit, and it has a particular amount of RAM, ROM, and number of IO ports, timers, serial ports which is required to perform the particular specific applications. So it makes easier for the programmer to write the programs as per the chip, and the execution also becomes faster, and cost also becomes less compared to microprocessor. These are main advantages of microcontroller. If you now you can compare, you can see the comparison between microprocessor and microcontroller. It has total 8 differences you can see in this table. As we discussed till now, so all are I am listed as a differences. If you see the microprocessor side, it contains arithmetic logic unit which has general purpose registers, stack pointers, program counter, interrupt circuits. Microcontroller, it contains microprocessor, nothing but whatever things are present in microprocessor, all those are present in microcontroller. Along with, in addition to that, it has inbuilt on chip memory, ROM, read only memory, and random access memory, IO devices, timers, and counters. And second comparison, it requires more hardware, and it increases size of the PCB. In microcontroller, it needs less hardware because almost everything comes with a built-in the RAM, ROM, IO timers, and counters, so it reduces the PCB size. Next difference is access time for memory and IO devices are more because you are connected externally. To access the memories, it needs time more for the operations, that makes less in microcontroller. And in microprocessor, you can see the more instructions to move the data between CPU and memories. In microcontroller, number of instructions are one or more to transfer the data from memory to CPU. In micro, and it is more flexible microprocessor because as per applications you can add the size of memories and timers, counters. But in microcontroller, it comes with the inbuilt, you can't change that one. You can't change the size of the memories, you can't change the number of timers. So before selection of microcontroller, you have to decide what would be the criteria you need to consider while choosing the microcontroller. That's why it is known as less flexible. Next, it is single memory map for data and code. In microcontroller, it has a separate memory map for code and data. Next, it few pins are multifunctional in microprocessor. If you see the pin diagram, you'll come to know that some pins only multifunctional. It is some pins are going to perform more than one function. In microcontroller, almost most of the pins, it is a 40 pin IC. So out of 40 pin IC, most of the pins are going to perform more than one functions. While studying pin diagram, you'll come to know that which are the pins are multifunctional. And in microprocessor, there are very less number of bit handling instructions. In microcontroller, it has more number of bit handling instructions. Bit handling instructions. While studying the instruction set, you will understand what will be the meaning of bit handling instructions. Next, we'll see the criteria. As you discussed before, perform any applications, and you have to decide which microcontroller you need as per your applications. The programmer or designer of the particular application has to decide. He has to consider some parameters if you want to select the micro, because there are different number of microcontrollers are available in the markets. So if you want to select the microcontroller, programmer should know what is the size of the program and what are the peripherals in need. According to that, he has to select the microcontroller. Here you are going to consider three parameters. First one, it should perform the required task efficiently and effectively. If you design any applications, finally output should be efficient and effectively. Maximum time it should give the almost 99.99% should be output should be accurate. To reach that effective or efficient results, you have to consider these parameters. In terms of, you have to take this parameter: speed, amount of RAM and ROM on chip, and power consumption. So these are very important while choosing the microcontroller. Next, number of IO pins. What are the number of, how many IO pins are available, and what are the multifunctions of each pins, and timers, how many timers are there on chip. Next, what are the cost per unit, because this is also important. If consider cost as a parameter, because finally the cost of I should not be exceeds. Easy of upgrading, that's also important. Time to time you have to upgrade your systems whenever if you want to add some more parameters or more applications to the your systems. Next, packaging in the sense of how the IC is going to manufactured, whether it is quad package or dual in package, like that. Next one, availability of software development tools such as compilers and assemblers and debuggers. This is related to software is one part of you are going to add to the every microcontroller to make hardware work. And here you are going to run different programs using the assemblers and debuggers and compilers. And during that, these are the development tools should be available in the market very easily to run all the programs, and it should check whether program is going to work as per our requirement or not. Next, availability of reliable source of for the microcontroller, and all the whatever sources are there for microcontroller, whether it is available, reliable, and whether it is all are reliable or not, you have to check it. Next, we'll discuss what are the different members are there in 805. If I say in the 805 microcontroller, there are different members are there. Apart from 8051, some other microcontrollers are also available, and in that case you will study what are the different members. There are two members, that is 8052 and 8031, and now we'll see what will be the differences between all these three 8051 family members according to the features. You can see the table, you will understand 8051, 8052, 8031. I am consider the main features like RAM bytes, timers, IO pins, serial port, and interrupt sources. 8051, it has ROM on chip is 4 kilobytes, RAM is 128 bytes, timers 2, IO pins 32, serial port is 1, interrupt sources are 6. Like that in 8052, 8031 also you have different size of ROM, RAM, timers, IO pins, and serial ports. You can see these are main difference between different families of 8051. Next important part of this unit is block diagram of 8051, and this is important questions. You will get it in the external exam for 10 marks, so please concentrate on this concept. In this architecture you can see the different whatever things it comes with the built-in. all those things, how it is connected internally. If you open the chip of 8051, it has CPU. For CPU you are connected external interrupts that through the interrupt control, and CPU will take the oscillator circuits by using oscillator crystal quartz crystal oscillator, and it has on chip ROM, that is to store the program code, and it has on chip RAM, and you have the two timers in 16-bit size, timer 1 and timer 0. That is, you can use those timers as a counters. For that you have to give the input pulses from the outside through the pins, that is why it's written counter inputs. Next, it has one serial port which is full duplex communication, which perform receiving as well as transmission, and it has four IO ports, that is P0, P1, P2, P3, and P0 and P2 P0 and P1 is used for address and data buses, and each port size is 8-bit. That means 8 pins each port has. Total 32 IO pins are available in 8051, and you have to control address bus and data bus. You have the bus control. These are main parts of your 8051, and these are main features. It has the CPU has two 8-bit registers, that is those are accumulator and B register. You have two 16-bit registers, PC program counter and data pointer. PC's program counter is one having 16-bit in size. Data pointer has also 16-bit in size. So the program counter mainly used to provide the address of every instructions which are written in the 8051. Data pointer is going to use to access the data which is connected externally from the external memory. It is mainly used to access the data which is stored in externally. Next, 8-bit program status word, that is used to know the status of each bit during the arithmetic operations. Next, 8-bit stack pointer. If you are using interrupt services, the stack pointer is very important while handling the interrupts. Next, it has 4 kilobytes of code memory, internal memory of 128 bytes, total 32 IO pins, 8-bit ports, two 16-bit timers T0 and T1 as you seen in the block diagram, and one serial port, that is known as full duplex serial data receiver and transmitters. Next, control registers. These are control registers which is going to control the different operations of timer, serial ports, interrupts and power controls, that is by using the specific registers like TCON, that means timer control, T-mode timer mode register, SCON means serial control registers, PCON in the sense power control registers, IP in the sense interrupt priority, which is going to set the priority of every interrupts, and IE means interrupt enabled registers. Next, two external and internal interrupt sources, and finally you are going to connect oscillators and clock circuits, which is going to measure the speed of execution of your programs which are written in the 8051. Next, that you can say the 8051 clock and instruction cycle, it is very important. Here crystal is connected actually outside the IC also. Sometimes it is comes with the inbuilt with the 8051. There are two pins are available, XTAL1 and XTAL2 is provided to connect the resonator to form the oscillators. Okay, this is going to operates between 1 megahertz to 16 megahertz. Generally operates with a crystal frequency of 11.0496 megahertz. And here if you consider one instruction cycle in the sense, it has total 6 states and each state has 2 pulses as you see in the diagram. Here one state S1 which has 2 pulses, like that you have total 6 states, each state has 2 pulses. Using this one we can measure the speed of every instructions within how much time it is going to execute. This is known as 8051 clock and instruction cycle. Now next we will study PSW and flag bits.